What do we think? Yep. So, I didn't change anything. So, the probability of them being an 8th grader, we take our favorable outcomes, our total number of 8th graders. So, our 180 out of everybody, 545. So, there's our unsimplified fraction. We need to simplify it, and you can do it by hand, or we can type the dang thing in the calculator. If you put it into the fraction, second column, third button down, we should get 36 over 109 is our simplified fraction. It does not look particularly simple, but it is simplified. And to get this, you just type it in the calculator. Or you could divide each of those things by 5 is what happens. Okay, so part B is a little bit different. Your sibling is in 6th grade. So given that your sibling is in 6th grade, means I know your sibling is in the 6th grade. What's the probability they like skiing? So we're going to set it up as an unsimplified fraction first. I know they're in 6th grade. Good catch there. I know they're in 6th grade, so they're somewhere in here. So the probability they like skiing is that 41 out of the 155. I know they're in 6th grade. It is a given. It is locked in. They wore their first day of 6th grade pin for school, first day of school. We know it. So then we're not asked for this as a simplified fraction. We're asked for this as a decimal. So how do we write 41 over 155 as a decimal? Yeah, so 0.265, 264516, blah, 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 blah. Watch our rounding. They do specifically tell us where to the round, and holy cow, do they want it rounded far? Because they want it rounded to the nearest 10th. So it would be 0.3. I will almost never ask you to round a probability to a 10th because that's a little aggressive. But we're following our instructions. Okay, questions on those two? Because it's been a hot minute since we did those. Yes, Meteor? I'm going to have to what? If so, I will tell you where. So it will say round to the nearest 10th, round to the nearest 100th. And that is part of my job this week is to make sure I go through and those are all there and all very clear. If it doesn't specify, I don't care. But they should specify because I don't want you guys to be wondering. All right, so number 2 is what we did yesterday. Calculating our mean, median, mode, and range. So what is our mean of this data set? I'm going to move my card out of the way. How do we find our mean? Add them all up. Divide by how many we got. We have 5 terms here, so we're going to add our 9 plus 7.4 plus 6.3 plus 8.1 plus 10.4. And we're going to divide by 5. So we should get 8.24. Exactly right. 8.24. Divide by 5 because we have 5 things there. What is our median? Middle number. $8.1 will be our median. We would need to put these in order in order to be able to find that. So I'll put them in order here. So our 6.3 and then 7.4 then 8.1, then 9, then 10.4. So the fact that these have decimals doesn't change any dang thing. How about our mode? Since I asked for it. Do we have a mode?
No.
No. Or technically everything. Because they all only happen once. We don't have any repeats. Mode is the most repeated. So we don't have any repeats. So you could argue nothing or everything, but rarely comes up. How about our range? That one we can do.
4.1.
How'd you find that out?
10.4 minus 6.3.
Gorgeous. 4.1. We did 10.4 minus 6.3, our highest minus our lowest. Okay. Questions on these? Okay. So what we're going to do today is we are going to finish out the packet. So we're going to start on page 18. We will do page 19, and then it'll be done. This is our last day. So where we ended yesterday was kind of right where this 3-box thing is, with some words in there that look really weird. There's some weird words we've not really heard before. And I'm going to talk this through, and in order to talk it through, I'm actually going to give us a little, like just how I did yesterday where I made up a data set. I'm going to make up a data set just to talk about it. So I'm going to cover this title up because you don't need it. We're on page 18. If we have a data set that looks like 1, 3, 5, 7, 9, I'm trying to make it do a thing, 11, and 13. There we go. Odd numbers. What's our median? We're on page 18. This is not in here. I'm just making this up so I can talk about something. 7's our median, right? So this is our median. We like that because it's a really good view of the middle. It shows us where the center of our data is. That's one of our measures of center. What we're going to do is we're going to talk about how we can talk about how close together all of our data points are. And what we do is we take our whole data, instead of just cutting it in half, because this is like, all right, here's our middle. So that means half the people are on that side and half the people are on that side. We're going to break them into smaller chunks. So once I take the median, I'm going to take my smaller side and find its median. What is this median of the smaller side? 3. You just calculated a lower quartile. That's all it is. So our lower quartile, which I did blue, is the median of the values below the main median, first median. So if the lower quartile is when I take the smaller numbers than my median and find my median, I can find my upper quartile, same vibe, just on the upper half. So bigger than the median, what's our median up there? 11. That's what our upper quartile is. What we're doing is we're taking the data and cutting it into quarters, literally into 4 pieces. So I have one section here, one section here, one section here, one section here. That's why they're called quartiles. It's literally cutting our data into 4 chunks. Okay, so our upper quartile is the median. Another way to word this is of the upper 50% of data. So literally cuts it into 4 chunks. We find the median, and then the median of the smaller numbers, and then the median of the bigger numbers. The last information we're going to be asked about is our inner quartile range. We talked about range yesterday. Our range was our biggest minus our smallest. So for my made-up data set up here, what's our range? 12, 13 minus 1. My inner quartile range is how far apart are those 2 weird quartile things we just found. So we're going to take our upper quartile, which we usually write down as UQ and LQ because quartile is an obnoxious word to try and spell. So our UQ, and we're going to take away our lower quartile. So we're looking for the difference in the quartiles. So for this particular set, I have 11 and 3. So what is my inner quartile range? 8. It is the difference between UQ and, that is a trash ant, holy cow, and LQ. All done? Awesome sauce. I don't know if you can put it on my keyboard right now. I'll take care of it. Okay. That's our last new words for the chapter. And we're going to practice with those today because it's a little weird to wrap our brains around, and the word quartile is obnoxiously, bougie. So the reason we need this is if you look at the picture down at the bottom of page 18, that has all of this information in it. So we're going to look at this. I'm going to let you pass it here. So we're going to look at this. Box plots are something that we do actually see in real life. These are available in the Canvas gradebook for every assignment that gets submitted on Canvas to show you where you are in the box plot. These come often on your SAT, NWEA, any of those test things that you do in school when they mail your parents the results. One of these will be on there. Sometimes they're sideways, sometimes they're up and down, but it's the same stuff. All right, and what this shows us is all that information we've been working with. What might the minimum data point be on this? 30. You're exactly right. Without me telling you a dang thing about this, we could figure out that this was our minimum. What might our maximum be? 220. Up here, this line is our maximum. Inside the box, and I know it's really hard to see because contrast is fun, there's a little line right there. Fully in the middle, that's going to be our median. So it shows our minimum, it shows our maximum, it shows our median. The edges of that box in the middle are also important pieces. They're not just a random width. It's our lower quartile and our upper quartile. So this edge is our lower quartile, and this edge is our upper quartile. And what this does, and why we have this visual representation, is it shows us that inside the box, right around our median, this is where half the people are. You should not be watching things, especially not watching things with people talking. Half of the people that were in our data, or half of our data points, are in this box. The other half are outside. So it shows us our middle half. That's why we have it. So it's a way of kind of showing how close together or how spread apart everybody is. And what we're going to do for the rest of the day, the entirety of page 19, is we are going to read another one of these, and then we are going to make one of these. and draw it ourselves. Okay, so that's what's on the next page. So we just read one of these. All we got to do is fill in the blanks. So we got a new one. And then I also am going to want us to put in a range as well, because I want us to practice that. So this one kind of looks wonky, but it's the same information. And when we have one that's kind of like this, where we have pieces that are in the middle, we're going to estimate, we're going to call it good, and we're going to move on with our lives. So about where do we think the minimum is? 25. I think so too, right here. This is our minimum, so the value is going to be about 25. If you say anything between 22 and 28, I will take it. Absolutely fine. It is not about you having to be exactly the same as me. Don't tell me it's 20, because it's very clearly not on the 20. And don't tell me it's 30, because it's very clearly in between. But as far as, well, I say it's 25, but you said it's 24, so wrong. I'm not that petty. I'm not that petty. Okay? All right, so where might our maximum be? 100. That's this guy up here. Where might our median be? Yeah, I would take anything between 80 and probably 83 would be my super happy window, because it's really hard to tell if it's right on 80. Maybe it's 80.5. Maybe it's 83 and their scale's a little weird. So I'll put 81 on here. That's my vibe on it, but I'm not mad about it. Okay? Again, I am not super petty. Don't tell me it's at 50, because it's clearly not. But as long as you're in the right neighborhood, we're okay. So then let's do our quartiles. Our lower quartile. 78, 79, somewhere around there. It's the edge of the box. I'll put 78. I heard that one first. I heard 79 louder, but I heard 78 first.
90.
Upper quartile. 89, 90, somewhere in that vicinity, right? Right there. And again, that's exactly my point. We might be saying, it doesn't look like it's right on the line. You might say, it looks like it's right on the line. I'm not petty.
That is right on the line.
I'm going to say 89.5 just to be right between the two of you. Ha 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 ha. Then. Just going right between you just to stop the argument. If, like, you both can be right, it's okay. Did make my inner quartile range obnoxious to find, but that's okay. We don't have to have the exact same answers. You can put the 90, that's okay. You can put the 89, that's okay. Just don't tell me it's on 100. Don't tell me it's 70. Get it in the right neighborhood. Do not stress about the pedantics, because I don't care. You've got the point. Okay? So our inner quartile range. Yeah, it's gonna depend on which ones you have. So if you have 89, it's gonna be 11. If you have 90, it's gonna be 12. So for mine, because I was obnoxious and went with decimal, mine's 11.5. Because I have a 0.5, because I put 89.5, so it's going right smack between the two, so you'd stop arguing. All right.
Because you have 90. Because I wanted to do 85.
And that's okay. And that's okay. All right. So our last, I want us to do one more data piece that's not on your list. I want us to find the range, just so we practice that again. So what is the range of our data set? Yeah, we take our maximum and take away our minimum. Max minus min, so it's 75 would be my range. So we want to look at this. Now I'm going to ask a question that we may or may not have enough information to answer. Do we suspect an outlier? Do we think there's one random, either really, really big or really, really small value? I was going to say, remember that the box has half our people. That means half the people are here, another quarter of the people are here. If a whole bunch of people are clustered right here, makes sense we got a whole bunch over here as well. It's really, really wonky,
It's
right?
25.
So we don't know enough to be able to have the exact value of an outlier, but yeah, since it's super duper wonky like this, yeah, there's probably an outlier. If it is tippy-tippy, like it looks like if I tried to balance it, it would go whoop. That's when it probably has an outlier. But we don't have enough information to say for sure. Okay, but most likely, a good kind of rule of thumb is if I can fit the box another time in here, there's probably an outlier. If my box, and here we got like a good 4 of them. So there is more than likely an outlier. Probably would be what I say. Probably. So if we have an outlier, this is just to refresh something we talked about at the very, very end of yesterday. If we have an outlier, which center should we use? Mean or median? This is like the very last thing I said yesterday. When we have an outlier, remember Jeff Bezos walking in the room? What happens to our mean? When Jeff Bezos walked in, our average income went way, way up, remember? Or if we were looking at the age in the room, hi, I'm your outlier. So when the outlier's in the room, your mean goes, whoo, very distracted. So if we probably have an outlier, our best center is going to be median. So that's just kind of where we ended yesterday, which is why I wanted to make sure we talked about it again, because sometimes the thing I say last is the very first thing to fall out of the brain. It's not going to be a super intense thing, but like I just wanted to make sure we mention it. Okay. Questions on this one? Because now we're going to make one and draw it ourselves. Boop. Data set. So we've got a data set. The numbers that we use to make the box and whisker are max, our min, our median, the lower quartile, and the upper quartile are called the 5-number summary because there are 5 of them. Min, max, median, lower quartile, upper quartile. So even in order there. So we're going to find all those pieces, which means what needs to happen first with our data? Least to greatest. I need them in order. So very first job is to put them in order. And I know there's a lot of pieces here, but this is literally our last thing. So we'll be aight. Two, and then 5, 7, 8, 9. Okay, it should look like this. So, starting with an easy question, what is our minimum? 2. What is our maximum? 18. What is our median? 10. It's right in the middle, circle it. I will always circle our median if it is an actual point. I promise it helps. Because now we're going to look for our lower quartile. Our lower quartile is the median of the numbers smaller than the median. I'm going to physically block the median. Look to the left. What is the median of that bit?
7.
7. It's actually right between these 7s. So our lower quartile, we find the median of this piece, which is right here, between those two 7s. But we average those two, and when I average 7 and 7, it's just 7. So our lower quartile is 7.
The same thing.
Mm-hmm.
Upper and
Our upper quartile is finding the median of the up here part. So again, I'm going to go bigger than my median. What is the median of that section?
14.
14. It's actually between the two 14s, but that still means it's 14. Because our median is right here. So our upper quartile is 14. I'm going to just put the number 10 with my median because I didn't actually write it. This is our 5-number summary. It has 1, 2, 3, 4, 5. It is also the 5 numbers we need in order to make our box plot. Questions on any of these or how we find any of them? You guys good or anything I can help with? Okay. So when we're drawing our box and whisker plot, or box plot, I tend to work from the outside in. So I'm going to take my minimum, which I have as this orange, and it gives me a little line right here, and my maximum, and it's going to give me a little line at 18. And every data point in my data set is somewhere between them. So there's a line that connects my smallest piece to my biggest piece. And what that actually shows right there is our range. The range is how wide is it? How wide is this? What is our range? Just to practice that as well. 16. Because my line right here is 16 spaces long. 18 minus 2. That's what the range is showing. It's how wide our data is. So the next pieces I'm going to do, I'm going to bring it in, and I'm going to do the edges of the box, which are my lower quartile and my upper quartile. So I'm going to have I did it up here in green, so I'm going to have a line at 7 for my lower quartile, and a line at 14 for my upper quartile, and that makes the box. The difference between my lower quartile and my upper quartile is also known as the width of the box. It's my inner quartile range, is how wide the box is. What is my inner quartile range here? My box is 7 spaces long. The box on this one is 7 spaces long. So our last piece to put in here is our median, which was right at 10, and that's another line. So everything just gets a line, a little vertical line, and we just connect them in weird ways. Okay? It's most important that we are able to read them, which you guys picked up super duper fast. You guys were shouting those numbers at me really, really fast. So it's most important that we're able to read them, but we also now can draw them. Okay? That is the end of chapter 1. Homework 6 is technically due today. When you turn in homework 6, pick up a copy of the chapter review. That is what we're going to work on tomorrow, and I'll let you guys choose if we do it together, if you guys just have time to work and ask questions. It doesn't matter to me. We can go either direction. But the test review is going to be right here. I'm going to put it on my little table just because otherwise it knocks stuff over. So I'm going to put it right here. You guys have almost 10 minutes until announcements start, where I get to holler them at you again today. Theoretically, next week we get video news, and I will no longer have to shout the announcements at you. Hopefully. Okay, but yeah, our chapter test is Friday. Yes, dear? Absolutely. All right. Work on stuff. Let me know if you got questions, etc., etc., etc. Boop, boop, boop. All right. What's that? Okay, so what margin of error is doing is it shows us how far away from the data that we got the real answer should be. Because we're working off of experimental data, it's not always right. Okay, so on something like this one, I'm just gonna use this real quick. This is just how I write it. They tell us that they did this survey and that their data from what they collected said 12% of the students did the thing. So we've got 12% as the middle. It's kind of like a median. All right, so it's the middle. That's what we have. And that they calculated, because there's a really, really long formula to calculate it, that more than likely the answer is within 3%. So it's either going to be 3% this way, where we subtract 3 and go this way, or it's going to be 3% this way, where we add 3. So 12 minus 3 is going to give us 9, and 12 plus 3 gives us 15. So what we know is that we can say most likely the real answer is between these two values. Okay, that's all it's asking. Okay, is all we can say is most likely, probably between them.
Okay.
We can't for sure, but more than likely. I'm not grateful for that, but I don't care. Oh, not a chance I will be there.